Well, we can go ahead and start with the material.
I guess it's a good thing I got here. Well,
Okay.
you'd have been all by yourself, recording all by yourself. Let me grab my notebook real quick for notes.
Okay.
Oh, man. Just in case I need it. I don't know that I will. So this was a good review of slope-intercept form. They use different terminology than what I'm familiar with, but
yeah,
it was a pretty good review. I need to study it a little, go back and re-study it a little bit more. I was pretty rushed this week with as much travel as I've had to do. I don't know if we're recording yet or not, but that's just having conversation with you while I get my stuff out.
We're having the intercept, the slope, we're having explanatory response variable,
Yep.
predicted body length. Different terms, same thing.
Yeah, I guess this is how slope-intercept form applies to statistics.
Yeah.
All right.
Okay. So do you have the preparation assignment sheet pulled up?
I do. Yep, I'm ready to go.
Okay. So then for number success, what is the explanatory variable? You will need to review the section in the while on the crocodiles to answer this question.
All right.
The explanatory was the head length.
Correct.
The first column.
Excuse me.
No worries. So that's correct, right? That's the head length on the specific sheet.
Yep. And the next one, it wants to know what the response variable, and we talked about that last week. The response variable is the body length in centimeters.
Yeah, correct. It was asking us to create a scatter plot representing the relationship between head length and body length. Paste your plot below. I just got a graph, straight, very straight. If we put it in the other term, strong.
Did you put yours just in the t-test for linear regression? Is that where you put yours?
Yeah.
Yeah, that's what I did as well. So, I mean, it's pretty straight. It's a little fat at the bottom, but
kind of. But yes, if we spread that out, it maintains the same direction.
Yep. So, I should probably make a quick copy of that and put it in the Word document while we're.
And that's what I just did, copy and paste into mine.
Go ahead and put that there while we're. Okay. Y-intercept in the regression line. Let's see, where was that at? Back intercept. Negative 69.369, if I remember correct.
Yes, that's the one. Then number 10, use the software to compute the slope of the regression line. I got 7.400.
And it is fairly nice having this Excel spreadsheet to help you out. I mean, it's
making all the calculations.
If you had to do all of this by hand, I would have hated to be a statistician even as far back as 1970, that would have been a pain in the butt. Imagine it.
You need to remember all formulas. I mean, actually, we need to remember those, but we save time by using a spreadsheet.
Yeah. 7.4. Okay, so what is the equation for the regression line computed by the software? Y hat equals minus 69.369 plus 7.4x.
Correct, yeah. That's the one. And then it says use the software to draw the regression line in the scatter plot. Insert the picture of a scatter plot with graph of the regression line superimposed over the data. But that's when I was not quite sure. It was just to place a straight line in between the information we had. Yes, and we are having some points above, some points below the graph.
Yeah. Let's see here. Is there insert a scatter plot with a regression line, right?
Yeah.
Did you I didn't get this one. I didn't get this one made up previously, so I'm trying to. How do you add the regression line?
I was just seeing the example on the internet, and they were just placing a line, a straight line following the direction of the graph, just to determine how straight the points are.
Okay.
Yeah.
Yeah. All right. Okay. Equation for a regression line computed by the software. Where's the regression line? See, but it says use the software to draw the regression line in the scatter plot.
Yeah, but that's what I was just seeing some examples because it was for the same graph.
Right. Well, I'll do a little more research so we're not hung up on that one. Okay. Find the observed head length of the 51 centimeters that was observed to the body length. And so whenever I looked at that in the Excel spreadsheet and just went down and matched, X to Y, it was 343 centimeters.
Yeah. Then it says use a regression line you obtain. And number 2 above to predict the body length based on a head length of 51 centimeters. So I just used the same formula. Y hat equal to negative 69.369. Plus, yeah, 7.4 times 51, and I came up with 308.031.
Right. $308.031.
Yes.
All righty. Excuse me. Why are the values you obtained in 8 and 9 different? Please explain. It's one of those where your data points aren't exact, whenever you're just trying to estimate. So that's why they could be different.
Correct, because with the regression line, they are asking a number 12. With that line, we are able to identify the point, the 51 centimeters, and it's not vary upon that line. So we have that gap in between those 2 points by just coming up with the data which is given on the spreadsheet, and then whenever we use the formula to calculate it. So it's not very accurate because it's not just passing upon the line, but just close to it.
Right. Right. Okay.
Okay. So then those were the questions. If you want, we can move on to the quiz.
Sure. Let's go ahead and see what we find. Let me get to the quiz here.
Yeah. Group and quiz.
All right.
This one is true. This one is true.
Come on. Come on. There we go. Group meeting. Group meeting quiz. Let's go there. Minimize, then maximize, so I can get the start quiz. There it is.
Yeah, that's very strange.
Does yours still do that, or was that just last semester?
I keep on doing it.
Okay, so it's not just me; it's yours as well, huh?
Yeah, last semester, whenever I wasn't able to find the button, I was like freaking out the first time, and then I just minimized it and maximized it up. The button that's on there.
Okay.
Okay, so that's question 3. Give the linear regression equation.
Let me ask you a question here real quick before we go on. This math self-efficacy, XLS, is that the same one as we used earlier in the week? Do you know? Or do I need?
Yes, it's the same.
Okay, because I still have that open, but if I needed to reopen it, I would, which
It's the same. I just downloaded and came as copy 1.
Okay, so it's the same one then. All right, so get my pencil here. All right. Thank you.
It says, given the linear regression y equal to 2.0 plus 1.5x, what is the y-intercept? Round to 1 decimal place. The intercept, it's the first one.
2.0.
2.0.
Okay. Given the linear regression equation, same one. What is the slope? 0.5.
Okay, 1.5. Then it says number 5, given the linear regression equation y equal negative 3.0 plus 0.25 times x, what is the value of y when x equal to 16?
So
this one
equals negative 3.0 plus
10.
X equals 16. 3.0 plus 2.5 times 16.
With 1.
Times 0.25 equals 4 plus 0.3 plus minus. All right, so 3 plus minus plus 0.25 times 16. 1 is what I get.
1.
All right, so for the next 7 questions, use the data file, math efficacy, confidence data for the exponential variables, and the score data for the response. So confidence is X.
Yes.
All right, confidence is X. So let me go back here to confidence, and score is Y.
Yes. So confidence, mean, let's copy and paste the data.
All right. So I swapped these the other go around. So if you remember last time we did that. So
yeah, I remember you swapped it. Then it says the score is Y.
Score is Y. So X goes in there first. Y goes in second. All right. That's not a very nice plot. Kind of ugly.
That's all together.
Yep. Okay. Excuse me. Excuse me. So let's look at this here.
This question is very interesting.
Okay. There we go. Make a scatter plot of the math self-efficacy data of the three data shapes introduced in the reading. Which shape best describes these data?
I would say it's a banana.
It is very similar to the banana, isn't it?
Yeah, a hot dog, I don't think so.
Let me look at that again. I don't know if there's enough. I don't know if there's enough curl. I don't. I don't think there's enough curl to be banana. I think you got one outlier down there at the very bottom, and everything else is so.
Yeah.
But I think it's more hot dog shaped than banana shaped.
Would like to go with hot dog?
I think so.
Okay, let's go with that one.
Let's see.
We'll see. It's funny.
I don't know. So I'm gonna.
It could be either or.
Yeah.
A hamburger, no. Then one or the other.
The scatter plot you produced in the last question. What can you say about the appropriateness of using simple linear regression to model these data? Let's see. Go back in reviews.
Based on the shot. I would say it's the first one. Simple linear regression is appropriate for this data.
Okay.
Because we have different graphs, and rather we have the ones that are reverse straight. It's not something that says that the graph does not qualify.
Right.
I would say it's the first one. Then it says how many, question 8 says how many observations are in the data. We have,
oh goodness, how many were there? Let's see here.
139.
Yep.
And it's asking what is the y-intercept. That one.
All right, what is the y-intercept?
18.690.
Double check here. 18.690. You're
For the slope, it's 12.695.
check that. Yep. What is the predicted value of y when x equals 4?
And so we have 18.90 plus 12.695 times 4. Let's see. 4 plus 90. I'm getting 69.47.
Plus 0.695 times 4. What did you get?
69.470.
For some reason, I got 70.55. So let me go back and make sure I entered the right numbers here. 18.690.
Yeah.
Plus 12.695 times 4, correct?
Yeah, 18.690
plus 69.47. Is that what you had originally?
Yeah.
I must have tabbed the wrong number in with my fat thumbs again.
Okay. It is asking for 3 decimal places. So it will be 69.470. That's number 12. Says the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Because there is a positive correlation, we can use the largest x value to find the largest predicted value of y.
So
This is the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? So we'll be use 6 as x.
I'm sorry, what's that?
To use number 6 as x.
Okay.
Yeah, because it says each question in a scale from 1 to 6. And it says what is the maximum predicted value of y for these values of x. So the maximum rank was 6. Okay, so will be then the 12.695 times 6 plus 18.690. It will be 94.860. Let me just do so again. Just in case I missed something.
77.86.
Yeah, I'm getting 94.860.
You're getting 94?
Yeah, I am getting 12.695 times 6. That's 76.17 plus 18.690. Yeah, 94.860.
94.860. I put the decimal in the wrong spot again with my big fat thumb. 94.860.
Yeah. Next one says, how many explanatory independent variables are present in simple linear regression?
How many?
We have 1, which is x.
Right. And your response, so you've got 1 because that's y, correct?
Yeah. And it says 15 a company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axis. Meaning the company wants to predict size of hat given the circumference. What is the response variable?
Wants to predict size of hat given the circumference.
The response variable is y, and they are wanting to predict the size because it's been predicted. The predicted, it's as well y, so they're wanting to predict size.
So the size of hat, because it's a variable being predicted, right?
Yes, the first option.
First option.
Okay, let's see.
See what we did here?
And 2, 2, 1, 1, 1, 1, 1, 1, 1, 1, and it's all fine, all perfect.
All right. Go team.
That's good work. So then with the draft, since we just fixed it, I'll send you a copy, and then I will go ahead and submit it as well.
Okay, sounds good.
Okay, so then thank you, Sean.
You bet. Have a good weekend.
You too as well. Have a good one. Bye-bye.